The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to today's webinar on the safe transportation of lithium batteries, what you need to know in 2021. This webinar is sponsored by the EPA's Sustainable Materials Management Web Academy. My name is Katie Harrison and I'm part of the webinar support team at ERG, which is a contractor supporting this effort. I will be managing the technical aspects of today's webinar. While we wait for the others to log on, I would like to cover a few housekeeping items. By now, you should have the GoToWebinar application running and should see the welcome presentation on your screen. There is also a control panel box on the right-hand side of your screen. Audio is available through your computer speakers, and due to high participation, there is no dial number for this webinar. All attendees have been muted to preserve audio quality. And if you have any technical difficulties using GoToWebinar, you can go to www.gotowebinar.com and click on the FAQs in the blue navigation bar on the left side of the page. We've noticed that sometimes a few attendees experience some technical issues on occasion with audio or viewing the slides during our webinar. While this is rare, if this happens, you may wish to leave the webinar and rejoin. This generally addresses this issue quickly and easily for you. If you need immediate technical assistance, you can email us at meetings@erg.com and we'll try to troubleshoot with you. This webinar will be recorded, and you can find a copy of the PowerPoint slides from this presentation in portable document format to download by clicking on the Handouts tab of your control panel. This SMM Web Academy presentation is a training session. There will not be a Q&A session today following the presentations. And after today's webinar, there will be a short evaluation. Please take a moment to fill it out. Your feedback is vital to helping us provide the highest quality speakers and information to meet your needs. This concludes my housekeeping items, so now I'll turn it over to Chris Newman from EPA's Great Lakes Region Office in Chicago, Illinois. Thanks for joining us today, Chris.
Thank you, Katie, and thanks to all of you for joining the April special edition of the Sustainable Materials Management Web Academy. We are happy to have you participating. This webinar is hosted by the U.S. Environmental Protection Agency to provide training and networking opportunities to state and local governments, non-governmental organizations, and other stakeholders interested in sustainable materials management. Today's special edition, an extended SMM webinar, will be led by subject matter experts from the U.S. Department of Transportation's Pipeline and Hazardous Materials Safety Administration, PHMSA. After a brief introduction about the importance of recycling lithium batteries, the webinar will focus on the safe transportation of lithium batteries for recycling, disposal, and reuse. Content discussed will include an overview of the latest regulatory requirements on proper lithium battery packaging, marketing, and labeling, as well as a basic understanding of how to apply PHMSA's hazardous materials regulations, the HMR. Electronics recycling has been a focus for many over the past 2 decades, and we've seen that stream of materials change from boxy computers to lightweight laptops. Cell phones shrink in size and increase in power, and everything has become wireless. What we've also seen happen is a switch to lithium batteries to power these devices. And while we all knew it was happening, not all parts of the waste management infrastructure were ready for this change and the challenge that these batteries present at end of life. Today, we're going to focus our attention on one part of the end-of-life management chain, transportation of small batteries from the electronics recycler or other last user to the battery recycler or sorting facility with our partners at the Pipeline and Hazardous Materials Safety Administration. Our speakers today will be Chris Newman, that's me. I'm an environmental scientist with the U.S. Environmental Protection Agency in the Great Lakes Region 5 office in Chicago, Illinois. Jordan Rivera is a transportation specialist with the U.S. Department of Transportation's Pipeline and Hazardous Materials Safety Administration. And Neil Suchik is a member of the Hazardous Materials Safety Assistance Team with PHMSA's Central Region. Moving on to today's webinar, please note the disclaimer. We'll leave this up for another 10 seconds or so for you to review. And now on to our speakers. A little more to introduce myself. Again, I'm Chris Newman, and I've been working on electronic waste issues at EPA for many years, focusing on outreach, coordination with the Region 5 and 7 states of the Midwest, e-waste program development of purchasing standards for computers, and addressing emerging issues like lithium batteries. Neil and Jordan are subject matter experts from the DOT and have been working on lithium-ion battery transportation. They've both done regulatory and field work related to lithium batteries, but focus on outreach and compliance assistance. Their goal is to make the DOT regulations easier to understand and to comply with, while spreading awareness of hazmat transportation safety. So without further ado, please welcome Jordan, Neil, and I. Today's session is a great opportunity to learn more about how to properly manage the transportation of lithium-ion batteries, as lithium batteries are becoming a key part of our everyday lives. Even looking at my not very cluttered desk here at home, I have 6 different devices with lithium batteries, which 10 years ago would have been just 1 or 2. This got me and others that work in electronics recycling wondering, how do we get used lithium batteries safely recycled? After learning of a few incidents during transportation, that question became, how do we safely get these batteries to the recycler? And that was the kernel that brought EPA together with our federal partners at US DOT's Pipeline and Hazardous Materials Safety Administration. Now for a quick overview of our agenda. We'll have a brief overview of batteries and how they work, EPA's involvement, the challenges presented, other federal activities, and then the battery shipping training. So a little bit about batteries. Consumer electronics have been moving to a portable world without wires for years now. Wireless headphones, wireless charging for your phone or your car, and smaller, more powerful, more portable devices. For the time being, at least, the chemistry of choice that's been settled on for our electronics, cars, and even storage on the electric grid is lithium, either as lithium metal single use or rechargeable lithium-ion batteries. For those of you that can remember back to the days of carbon zinc batteries or even nickel cadmium batteries, batteries have come a long way in terms of size and performance. In the past 15 years, we've seen these and other types of batteries take a back seat to lithium batteries in many applications because of lithium batteries' energy density, form factor, and durability. Lithium batteries pack the charge that we need for all-day power in a smaller package that can be unobtrusively fit into many devices, sometimes without the consumer knowing it's even there. Really, at the time of the creation of lithium-ion battery, many of the devices that we have today would have seemed like science fiction to me. And I'm sure there are more devices being dreamed up right now that seem that way. But at the end of life for these batteries, or these devices, or the battery, we need to get them safely recycled so we can get these materials into the next generation of products. And safe transportation is a key part of safe recycling. Now let's have a quick primer on how these batteries work. There are 2 types of lithium batteries. One is the non-rechargeable primary battery that uses an anode made of lithium. The anode is the negative terminal of the battery. 2 examples of these single-use batteries are often seen as replacements for common AA or 9-volt alkaline batteries or coin cells. The other type of battery are the rechargeable lithium polymer or lithium-ion batteries that we have a diagram of on the slide. In these batteries, the lithium ions, hence the name lithium-ion, is in the electrolyte, which is a liquid or paste, and the ions travel between the anode and the cathode, which is the positive battery terminal, to create the voltage. There is a thin sheet of polymer, hence the name lithium polymer, or plastic, that has holes in it just large enough to regulate the flow of the lithium ions from one side to the other, creating the electricity that powers our devices. These batteries can be a variety of shapes and sizes. From lithium's place on the periodic table, it's the lightest solid metal and very reactive. We can use its properties in lithium batteries to make batteries lighter, have a higher charge density, and have higher voltages than other types of batteries. The reactivity of materials in the batteries and the potential of the batteries to have some remaining charge when the device is no longer able to operate are a key part of why we're here today. Okay, that is the end of today's chemistry lesson. Now we're going to talk about some technical information on lithium-ion batteries. There are a few things that make lithium-ion batteries different than the technologies that preceded them. Lithium-ion batteries have a higher voltage. Where an alkaline battery would have had a voltage of about 1.5 volts, a nickel-cadmium battery would have been about 1.2 volts. A lithium-ion battery can have over 3 volts of charge. Where 2 alkaline batteries were needed to make a product work before, we can now use one smaller lithium battery, helping to shrink product size. Lithium-ion batteries may not be rechargeable if the state of charge of the battery is less than 30%, so the device may be designed to shut down when the state of charge is about 30%. This means that a battery that won't power a device isn't dead, but could still have a voltage that could cause a short circuit if not properly packaged for shipping. The materials encasing the battery are designed to keep air and moisture away from the electrolyte and keep the battery contained. But some of these materials inside are flammable when they meet the air. The packaging is designed to allow for swelling and is relatively sturdy, but if it's crushed in a recycling facility, it can quickly lead to further problems. And many devices aren't labeled that they contain a battery. Take this photo of a control board and battery from a selfie stick. Both the battery and the control board aren't too much larger than a quarter, and there was no labeling on the product. And at the end of life, many people might not have given the presence of a battery a second thought before sending it on to its final destination, either a recycler or disposal. So what started getting EPA staff attention to the challenges these batteries pose? While EPA staff was participating in the development of a standard for sustainable computers, we began seeing that in some cases, these batteries could be limiting the life of an electronic device, such as a laptop computer, because the battery isn't removable when it's unable to provide sufficient power. If the user or the next user isn't able to replace this battery and the device is recycled or disposed of, we can lose all the embedded energy and materials in those products. Like I mentioned, EPA staff was involved in some standards development. One in particular was IEEE 1680.1, which is a standard for sustainable desktop computers, laptops, and monitors. During this work, it was highlighted that embedded batteries can impact product life. We saw that batteries are strongly attached to electronics for product safety reasons. Worn out batteries can lead to product obsolescence and replacement while the rest of the device is fine. Trying to remove the battery from a device can damage the battery or device. And then questions came up about where consumers would put these removed batteries if they did remove them. And then it became a sustainability and end-of-life issue when we learned about recyclers having incidents with thermal events of these batteries and also during thermal events during transportation. As EPA staff started talking more about battery removability, we started hearing about the issues that electronics recyclers were having with lithium-ion batteries catching fire when they were removed from a device, or fires starting in other parts of the waste management infrastructure. Then finally, we started seeing more in the press about the issue. There was the fire that destroyed a material recovery facility for residential recyclables in California, the explosion of a shipping container on a freight train in Houston, several additional waste management fires, and then a Washington Post article on a Wisconsin electronic recyclers experience. This article was a very in-depth look at one of recyclers' experience and how they needed to deal with these batteries. But we aren't here to talk about the safety of lithium battery products in this webinar. Today we'll be focusing on the end-of-life transportation. Going back to the experiences we were hearing from the electronics recycling industry, these thermal events, which includes fires, are not uncommon in the electronics recycling industry. We heard from the industry that facilities are prepared for them, as they may happen a few times a month. The glues or adhesives that hold the battery in place are very strong so that the battery doesn't shift or isn't damaged during use. The adhesives can pose challenges to the person removing the battery or others working at the facility if a significant thermal event occurs while the battery is being removed. Batteries also need to be removed carefully, for example, to avoid damage from being punctured or excessively bent. In these photos, you can see what happened when a tablet was opened and somehow the battery became damaged, catching fire. These types of events were the ones that were catching EPA staff's attention. What also caught our attention was that these fires were happening not just at electronics recycling facilities, but like I mentioned earlier, but also in the waste management and transportation infrastructure as well. It's my understanding that electronics recyclers have become more adept at dealing with batteries that are having issues. They have trained staff and safety equipment on hand to be able to manage a battery at the first sign of trouble. EPA staff also heard about transportation-related fires. Over the years, package shipping trucks have caught fire. There was the railroad explosion in Houston that I mentioned earlier, and even an incident with an air freighter. But we need safe ways for these batteries to get to the recyclers without damaging the transportation infrastructure. If we can't get batteries to the recyclers or refurbishers, we're going to lose opportunities for electronics reuse and recycling. We're also going to lose the already extracted and processed materials and minerals that could be part of the next generation of products. And we can also put the people that work in the transportation infrastructure at risk. The US DOT regulations that we're going to be learning about today will help us safely get batteries to recyclers. And why do we want to get these batteries safely to recyclers? The forecasted growth in demand for lithium batteries is huge. Some sources say that in the period between 2015 and 2030, the volume of installed lithium batteries will increase multiple times, while the number of applications will also be increasing. Materials used in battery production include anodes, cathodes, separators, and electrolytes. Key battery metals include lithium, nickel, and cobalt, for which competition will also be increasing. We're also seeing the widespread electrification of many products that used to be almost exclusively fossil fuel based, starting to use powerful batteries instead as their energy source. These can help improve air quality and even reduce noise in our communities, and can even lower operational costs. So you can see here in this graph how demand is expected to take off over the coming years. EPA staff and staff at other federal agencies, as well as private industry, are concerned about the competition for the chemical elements that batteries use. In this slide, you will see one aspect of that competition, that the electronics sector will have competition from the automotive, energy, and industrial sectors for many of the materials used in lithium-ion batteries, possibly to make products for those industries, possibly to make batteries as well for those industries. In addition to lithium-ion batteries contain materials such as cobalt and graphite, which are highlighted with the red arrows, that are considered critical in supply by the US Geological Survey. So it's important to ensure that these are managed for maximum recovery. At this time, we're able to recover cobalt and lithium for use in new batteries. Other key materials like graphite are not recovered for reuse at this time due to technical issues with its recovery. So it's key that society works on ways to recover and recycle batteries that are at their end of life to provide materials for the next generation of batteries. And it's very important that recovered batteries be shipped safely to protect life and property. So once we've safely shipped our batteries, how do these batteries get recycled? Generally, and there may be differences between programs, the batteries are collected at a collection point, which could be a retailer that sells rechargeable batteries or a household hazardous waste collection event. They could also be collected at private collection boxes that a commercial generator would use, or even an electronics recycler that's moving rechargeable batteries from devices. At this point, the batteries should be properly managed and packed for shipping. The DOT presenters will be talking more about this. Then used batteries are shipped to a sorting facility where they are sorted by chemistry, lithium-ion, for example, or nickel-cadmium. From there, they are sent on to a processor for recycling. It's possible that a site that's dealing with larger amounts of the same type of batteries could send their used batteries directly to a processor. Then the processor will use either high temperatures to melt and separate the materials in the battery, or they will use an acid to dissolve the battery and recover the metals from the liquid. The metals of interest are then separated and prepared for reuse. There are some new technologies also being talked about to recover these materials as well. So we'll see what's on the horizon. This is the general flow for batteries that are in good condition. If it's a damaged, defective, or recalled battery, there are different packaging requirements that the DOT presenters will be talking about, and they may be recycled differently. So, Between the time that these batteries are at their end of life and are recycled, there are some regulations that apply under the Resource Conservation and Recovery Act. Many people have questions about this. Depending on their specific chemistry, used batteries can exhibit one or more of the characteristics of hazardous waste per 40 CFR Part 261 Subpart C. Hazardous waste batteries may be regulated as universal waste per 40 CFR Part 273. Household batteries are exempt from the hazardous waste standards and are not affected by the universal waste regulations. Batteries from facilities with very small quantity generator status are also not affected by the universal waste regulations. And below this, you can see 2 links to other web resources, and these links are available in the PDFs in the handout section. I also want to mention that most states implement their own hazardous waste program and may have more stringent regulations. Often in the federal government, agencies and programs work on a certain topic in a specific area of the agency, and there's not much overlap with another agency's work. However, in the case of lithium batteries, there's lots of work being done by several agencies to address issues in the entire life cycle. Staff at various federal agencies have seen new needs and challenges arise from the use of these batteries. There are questions about recycling, regulation, and transportation, which we're here to talk about today. At this time, EPA, the Department of Transportation, and the Department of Energy are working on various aspects of used battery management. EPA is addressing the waste management and recycling aspects of these batteries with several webinars and presentations, engagements with stakeholder groups, and is addressing how these batteries are regulated when they become waste. The agency has posted 2 new web pages on batteries in general and lithium batteries as well. And again, those links are available in the document in the handout section. DOT is addressing the safe transportation of batteries through these training sessions that the Pipeline and Hazardous Materials Safety Administration is presenting. And I want to thank them again for all the work that they put into developing and presenting these sessions across the country over the last 2 years. The Department of Energy has the Battery Recycling Prize, which focuses on identifying innovative solutions for collecting, sorting, storing, and transporting spent and discarded lithium-ion batteries from electric vehicles, consumer electronics, industrial, and stationary applications for eventual recycling and materials recovery. And the Consumer Product Safety Commission is also addressing product safety issues related to these batteries. There also may be additional efforts going on in other agencies and departments that aren't mentioned here. So, thank you again for being with us today. I think we're all ready for the main event. So I'd like to turn it over to Jordan Rivera and Neil Suchik from the Pipeline and Hazardous Materials Safety Administration to talk about shipping these batteries. Jordan and Neil, the floor is all yours.
Thanks, Chris. Hello, good afternoon or good morning. My name is Neil Suchik, and I am the Hazardous Materials Safety Assistance Team member for the Pipeline and Hazardous Materials Safety Administration, or PHMSA. I'm based out of our central region, and I'm located in Chicago, Illinois. Also with me is Jordan Rivera. Thank you so much for joining us for our presentation on recycling lithium batteries. Today, over the next about hour and a half, we're going to discuss the DOT regulations around battery recycling and reuse. So our goal today is to get you more familiar with what the regulations are, how to apply them, and work within them confidently. So we wanted to put our contact information up here first. This is Jordan and I's contact information, our email, phone number. We wanted to give you this out front for folks who might not be able to stick around for the whole presentation. We're asking basically just get in touch with us if you have questions about battery transportation, especially when it comes to recycling, reuse, or e-scrapping. And also, if you have experiences to share about working in these industries, like best practices or maybe interesting situations or stories, we'd really love to hear from you. It really helps us better understand the industry at large as we talk to folks throughout the country. Before we begin, I want to remind everyone that when you're determining compliance with federal regulations, DOT always advises you to use the hazardous materials regulations. That might seem pretty obvious, but we want you basically to know that these slides are purely informational and not to be used as a standalone compliance tool. So while we hope this is helpful for a broad overview, you should always consult the regulations and reach out with questions. EPA provided us an excellent overview of lithium battery recycling and the ever-growing need for sustainability with our energy resources. But why is DOT here? Let's take a look at why lithium batteries are considered a hazardous material and the specific transportation requirements for them. Lithium batteries contain substantially more energy than other batteries, and this energy is only increasing as technology improves. These batteries have flammable electrolyte with a very high energy density as compared to other chemistries of batteries of a similar size. Improperly packaged lithium batteries present a significant risk of a serious incident and the release of stored energy. Thermal runaway leads to self-heating and the release of that stored energy. The result is fire, explosion, and release of flammable gases. We've seen incident reports involving lithium batteries intended for recycling, and we've heard from industry about other incidents. There are constant news stories about hazardous materials incidents, especially related to lithium batteries. The industry is also seeing an increased quantity of end-of-life or second-life batteries, along with increased lithium battery production to meet the demand for electronics and electric vehicles. For all these reasons, this topic is extremely important now and is going to become increasingly important as time goes on, and even more of our energy needs are fulfilled by lithium batteries. I want to show you a video that demonstrates the energy capacity and the risks associated with lithium batteries. So we have a couple of videos to show you. This first one is courtesy of the University of Michigan's College of Engineering, and it really does an excellent job of explaining why we experience lithium batteries incidents from someone much more intelligent than I am. So let's watch.
Just like a tank of gasoline or a bullet in a gun, a battery has a lot of energy in it. And if that energy is released in a way that we don't want it to be released, a fire can occur or even an explosion. Nowadays, lithium-ion batteries are used in pretty much everything from children's toys to laptop computers, our cell phones, power tools, and even some vehicles. If there was a simple way to describe why a battery would catch fire and explode, there'd be a simple way to prevent it from happening. There's a lot of pieces and processes that go into making the battery work. If any of those processes go wrong, there's a chance for energy to be released. And the reason that happens really is because the electrolyte inside of the battery is an organic solvent, and that solvent is flammable. So if the battery can't vent, you build up pressure as the electrolyte burns, and then it explodes. Thousands of these things are being made per hour, if not hundreds of thousands. And in that mass production process, if something goes wrong even a little bit, it might be very difficult to catch, but small mistakes lead to big problems down the line. In previous instances of batteries catching fire, the cause has been bad welds. A lot of the pieces of the battery are welded together, and if you don't have a good weld, you develop resistance. The resistance develops heat. Heat leads to fire. Other times it has been because of contaminants during the building process. Contaminants were generated, a little bit of metal scraped inside of a machine, and that contaminant fell into the cell, and that caused a hard short between the anode and cathode, which then generated heat, and so on and so forth. Generally, there's lots of different approaches that are being looked at on ways to make batteries safer. Really, the cutting edge approach, what's being looked at here on campus, is an all solid state electrolyte. So we would remove the flammable liquid entirely from the cell and just put down a ceramic layer that is capable of conducting lithium ions but not electrons, to allow the anode and cathode to talk to each other in a way that is functional and not going to short out the cell. You know, there are lithium-ion batteries everywhere around us all of the time, and the vast majority of cases, nothing goes wrong. A battery is stored energy. Whenever you have stored energy, there's the potential for that energy to be released in a way that we don't want it to be. Accidents do happen, but to combat that, there are professors here on campus, including Dr. Sakamoto and Dr. Dasgupta, who are looking at different ways to make batteries and make them safer for future use.
Thank you to Dr. Les and the University of Michigan for that video. Next, let's take a look at what a lithium battery fire looks like in a consumer electronic device. So what this video is demonstrating is thermal runaway in a lithium battery. And the thing I want you to pay attention to is the timer in the top right-hand corner. So what you'll see is just how quickly a thermal runaway situation can evolve, and sort of the way it develops from, that initial spark to well, I guess we'll see what happens next. So as you can see, all that happens in the matter of about a minute and a half. And so I've seen at recyclers, and maybe if you have a recycling facility or a collection facility, I've seen piles of sand sitting around. It's a pretty low-tech way of dealing with thermal runaway, but it is pretty effective. So yeah, that video shows just one small lithium battery laptop and just how much power and stored energy is in there, and what it can do in the event of a thermal runaway. Another example of the implications of a lithium battery incident was demonstrated with this occurrence near Houston, Texas in April of 2017. It shows the consequences that occurred as a result of lithium batteries being transported for recycling and disposal, but were not properly identified and packaged. It was determined by investigators that the most likely cause of the fire was lithium-ion cells that began thermal runaway in one of the steel drums. Thermal runaway propagation in the drum caused the cells to vent flammable gases, which created an even larger buildup of gases in the shipping container. An explosion occurred due to the extreme rise in pressure. The subsequent fire resulted from the excess heat generated by thermal runaway. And the investigation revealed that the batteries were most likely incorrectly packaged, and their presence was not communicated to carriers. So now, between EPA's presentation and those demonstrations, we have a pretty good understanding of why lithium batteries are considered a hazardous material. So let's take a look at what we'll cover during today's presentation. Here's the agenda for the remainder of the presentation. We're going to begin by giving you an overview of the DOT and PHMSA. We'll talk specifically about what the DOT has jurisdiction over and how the department is structurally set up. Then we'll talk specifically about PHMSA, which is the lead operating administration regulating the transportation of hazardous materials like lithium batteries. That's where Jordan and I work. Next, we'll tie the DOT and PHMSA mission directly into the used battery supply chain to clarify how PHMSA's jurisdiction applies to certain portions of that supply chain. Then we're going to dig into the actual regulations. So we'll cover topics like battery identification, packaging, and hazard communication requirements. Our goal here is to give you as much guidance as possible to make working within the parameters of the regulations as straightforward as possible. This is a great moment to take a look at the handouts portion of GoToWebinar and pull up the PDF document. In there we have our slides, and in there you'll see hyperlinks, and what we've tried to do is include hyperlinks to the actual parts of the regulation that we're going to be covering today so you can follow along if you'd like. Specifically, we're also going to talk about some relevant special topics, and what I mean by that is we're going to talk about damaged battery regulations, so damaged effective recall or DDR batteries, and DOT special permits. Special permits are very common within the recycling industry, so we'll touch on what DOT special permits are and give you some examples. Jordan's going to get us started with the first two parts. Jordan, you want to take it away?
Thanks, Neil. So as Chris kind of talked about before, because there are many relevant regulators out there, especially in this industry, we find it's helpful to just get started by giving a quick overview of the DOT organizational structure and clarify who PHMSA is and what we regulate. We think it's super helpful just to know who you can talk to about certain regulations and requirements. So the mission of the Department of Transportation is to ensure that the U.S. has the safest, most efficient, and modern transportation system in the world that improves the quality of life for all American people and communities, from rural to urban, and increases the productivity and competitiveness of American workers and businesses. So operationally, the DOT accomplishes this mission through its operating administrations, each of which have a specific mission that is tied to that overall DOT mission. So, for example, the FAA that you see there, possibly the most widely known operating administration of DOT, ensures safe aviation and aerospace. PHMSA, our agency, is one of the DOT's operating administrations, and we're divided into two offices. So the first office is the Office of Pipeline Safety, which is responsible for carrying out a national program to ensure the safe, reliable, and environmentally sound operation of the nation's natural gas and hazardous liquid pipeline transportation system. And our office, the Office of Hazardous Materials Safety, carries out a national program, including security matters, to protect against the risks to life and property inherent to the transportation of hazardous materials in commerce by all transportation modes. So PHMSA has a nationwide presence via its regional offices, headquarters where I'm located is in Washington, D.C., and the regional offices will house most of our investigators and field support staff, like our hazardous materials safety assistance team, where Neil works. So this is PHMSA's mission at the core of everything we do. PHMSA accomplishes this mission by establishing national policy, setting and enforcing standards, educating, and conducting research to prevent incidents. We also prepare the public and first responders to reduce consequences if an incident does occur through outreach and the Emergency Response Guidebook, or ERG. And this mission is promulgated through the federal hazmat laws. So U.S. Code grants regulatory authority over hazmat transportation and commerce to the Secretary of Transportation. The DOT regulates hazmat transportation primarily through PHMSA. You can note that this purpose here is very similar to PHMSA's mission statement. And we put commerce in bold because it's just important to note that we only regulate the transportation of hazardous materials in commerce. So private individuals, for example, transporting hazmat for non-commercial purposes in a private motor vehicle, or government entities transporting hazmat for government purposes are specifically accepted from these regulations. So PHMSA carries out this mission through these main functions, though there are others. First, regulations. So we formulate, issue, revise, and interpret the hazardous materials regulations. This is done by our Office of Standards and Rulemaking, along with our Office of Chief Counsel. We issue special permits and approvals under the federal hazmat law, which includes the DOT special permits for lithium battery recycling, which we will talk about later on in the presentation. Enforcement, so PHMSA enforces and inspects stakeholders like packaging manufacturers, multimodal shippers of hazmat, and we'll work with our modal partners from other operating administrations for enforcement like Federal Motor Carriers, Safety Administration, and FAA. And then finally, outreach and engagement. So we support regulatory compliance through development of compliance materials and trainings. We'll conduct outreach activities like hosting workshops like this one, networking with industry, and leading up strategic compliance initiatives like our undeclared hazmat initiative, Check the Box, which was recently featured on James Corden if you're a fan of late night TV. So we just talked a bit about DOT, PHMSA, and our mission. So now we want to connect that to our role in this supply chain. So because lithium batteries are hazardous materials, PHMSA regulates the movement of lithium batteries from location to location, including how the batteries are packaged for that transport. PHMSA's jurisdiction over battery recycling or reuse is fairly limited in scope just based on our purview of regulating transportation and commerce. So, for example, DOT does not regulate where, how, or even if batteries are recycled or used. Here's a visual of the battery recycling supply chain that calls out the specific actions that are subject to DOT hazmat transportation regulations. So DOT, again, has oversight over the transportation process, which includes identifying or classifying batteries, how those batteries are prepared and packaged for transport, the hazard communication on packages, and then the movement of those batteries. So regardless of whether you're involved in scrapping or battery collection, or you're a sorter, or you're an e-waste recycler or refurbisher, if at any point you package and prepare lithium batteries for transportation and commerce, then these transportation regulations are relevant for you. And next, we'll kind of talk more about all of these, specific regulations within these segments of transportation. So now we'll get into the next part. How do these regulations actually apply? So we want to discuss the DOT hazmat transportation regulations with an emphasis on how they work in practice. These regulations are commonly referred to as the HMR, and they cover all modes of transportation. The regulations will all generally fall into four main areas. The first area is identification and classification, which covers what are the hazardous materials and what kind of hazards do they present. The second area is hazard communication, so regulations on how the hazards of the material are communicated while it's in transportation. The third area, packaging requirements, which covers how a material needs to be packaged while in transportation to mitigate its risks and to prevent its release into the environment. And then the fourth area of the regulations cover operational rules. So these are modal specific regulations that are mainly for carriers and transporters of a packaged material when it's in transit. So understanding the basic structure and outline of where in the regulations certain requirements are found is important in understanding how to use the regulations when you're actually kind of referencing the regulatory text. So here are some of the higher level topic areas in section 173.185 of the regulations, divided out by paragraphs. So the first is classification, which specifies that in order to be transported, all lithium batteries must be of a type that have been successfully tested to withstand specific conditions. These tests are known as the 38.3 tests, and battery manufacturers are required to ensure that battery designs meet this standard. Second is packaging, paragraph B. This is where you're going to find the actual regulatory text for packaging requirements. The third paragraph, paragraph C, would be the small battery exceptions. These provide exceptions from certain packaging requirements and exceptions from standard hazard communication or DOT hazmat employee training requirements. These exceptions are contingent on the energy capacity of the lithium batteries, and they can vary depending on mode of transport and package quantities. So it's just very important to note now that while the regulations and we use the term small to describe a battery, this is generally referring to the energy capacity of the battery, not necessarily the physical size of the battery. So going forward, if size is mentioned, note that we're referring to energy capacity. The fourth paragraph of note here, paragraph D, provides exceptions for disposal and recycling. So this provides exceptions from those UN 38.3 testing requirements and UN specification packaging requirements. Now, Neil will talk a little more later about what UN specification packaging is, but for now, just know that it refers to packaging that has been specifically designed and tested to contain hazardous materials. Now, these recycling and disposal exceptions can be used in addition to small battery exceptions, which is another thing Neil will cover. The important thing to note, though, is that these exceptions are limited to motor vehicle transportation only. And then the fifth and final paragraph we'll kind of talk about would be for damaged, defective, and recalled batteries, also known as DDR batteries. And this paragraph, paragraph F, provides conditions through which DDR batteries can be transported. And we're talking about here those batteries that have a potential of producing a dangerous evolution of heat, fire, or short circuit. So the biggest exception for recycling and disposal of batteries, like I mentioned, is the exception from UN 38.3 testing requirements and UN specification packaging requirements. This exception can also be combined with small battery exceptions, which provide certain packaging and hazard communication exceptions. Just remember, these exceptions are limited to highway and motor vehicle transportation only. So vessel and rail are examples of transport where you are not accepted, for example, for knowing that a battery was successfully tested, and even for recycling and disposal purposes. Now, just a quick note for any refurbishers out there. The key distinction when you're talking about transporting batteries for reuse as opposed to recycling and disposal is that batteries that are being shipped for reuse must be treated like new batteries, which means that they're not accepted from being UN tested batteries. And you can verify this testing with battery manufacturers or product documentation. Batteries sent for reuse are still eligible for small battery exceptions, again, depending on the energy capacity and the quantities. And Neil is going to cover kind of making this determination. There's also no blanket exception from UN specification packaging by any mode of transport, which means depending on the energy capacity and the quantity of the batteries you're shipping, UN specification packaging may be required, which Neil will talk later about when UN specification packaging is specifically required. So with that, I'll turn it back over to Neil, who's going to discuss the three major components of compliance.
Thanks, Jordan. So DOT compliance, at least when we're talking about, specifically lithium battery transportation for recycling or reuse, can be thought of as having three major prongs. So the first is going to be classification, so identifying what the hazard is. The second is containment, so packaging the hazardous material. And third is communication, so telling those on the outside of the hazards within the package. Classifying the hazard is the most important aspect of the regulations. All your requirements, so from correct packaging to hazard communication and emergency response, are determined by how a hazardous material is classified. So this is especially important for batteries. Some batteries, like alkaline batteries, have very few requirements, whereas lithium batteries present a much greater risk and have specific packaging and hazard communication requirements. This is how identification and proper sorting are affected by the regulations. DOT organizes our hazards by hazard class, each of which is a specific definition based on technical criteria. So those hazard classes are seen here. And that bottom row of enlarged hazard class labels you see represents the ones you're most often going to come across in the battery recycling industry. Class 8 batteries are where you'll find lead acid batteries, so like your traditional car battery. Lithium batteries fall into hazard class 9, which is a miscellaneous hazard class that includes many different types of hazardous materials, but unlike those other hazard class 9 materials, there is a specific class 9 lithium battery label. So in the lithium battery recycling supply chain, classifying the hazardous material is essentially done when you're sorting the batteries based on chemistry and identifying lithium batteries. So as a lot of you out there probably know, this process is largely a manual one with little automation. We've been made aware that there's multi-day training classes that cover battery identification. So if your job function includes sorting batteries by chemistry, it would definitely be beneficial to attend one of those. And in our conversations with large battery recyclers, we found some methods being used in the industry to identify batteries. And this is not information you're going to find in the regulations, as battery designs can vary from manufacturer to manufacturer. So the first and most reliable method is identifying battery markings. So some batteries, such as lithium-ion batteries, will be marked with a specific battery chemistry. Again, this is the most reliable method of identification and should be your primary means of identifying a lithium battery. The second method is identifying physical characteristics. So for example, some lithium batteries may have vents as part of their physical design. The battery voltage can also give you an indication of the battery chemistry. And definitely the least reliable method to identifying battery is color. Maybe colloquially, there's been some identification or association between certain battery types and certain colors. For example, lithium, being blue, or NiCad batteries being yellow. This is not a reliable way to identify a battery, as colors can vary widely, so it is not recommended by anyone to ever go off color alone to identify or classify batteries. And also, the sorting process is where you're going to be removing and isolating any batteries you suspect may be damaged, defective, or recalled, known as DDR batteries. These batteries present a far greater risk in the supply chain and have very specific and stringent transportation requirements. Jordan's going to talk about how to identify DDR batteries a little bit more and their requirements coming up. So one of the other big challenges we've heard is that in recycling lithium batteries or reusing lithium batteries, you may not know the battery's history. So you may want to look at safety data sheets or SDSs or contact manufacturers if you have no other indicators of what the chemistry is or the energy capacity of the battery is. For the purposes of the regulations, lithium batteries fall into two basic categories: lithium metal, which includes lithium alloy, in other words, primary lithium batteries, and lithium ion, including lithium ion polymer, or secondary lithium batteries. As the name indicates, lithium metal batteries contain a small amount of metallic lithium or a lithium alloy. The lithium content in these cells and batteries ranges from a fraction of a gram to a few grams, and typical geometries include coin cells, cylindrical batteries, or rectangular shapes. Conversely, lithium-ion cells and batteries contain a lithium compound, such as lithium cobalt dioxide or lithium iron phosphate. Lithium-ion batteries are generally rechargeable and most often found in laptops, cell phones, and tablets, and power tools. Your common configurations are cylindrical, pouch, and rectangular. So let's take a look at some examples. So by no means are these examples going to be all-inclusive, but we wanted to show you what some examples of non-rechargeable lithium metal batteries might look like. So think of your coin cell batteries, like watch batteries, or other batteries that cannot be recharged. Again, these are containing a small amount of lithium, metallic lithium, or lithium alloy. You can see there are battery markings on here indicating that they are lithium batteries. Now let's take a look at some examples of lithium-ion batteries. Think your laptop batteries, cell phone batteries, the batteries that are rechargeable. These contain a lithium compound. And then notice on these pictures, the written indication of the battery chemistry on some of these examples. It's seen as lithium-ion or written out telling you the lithium compound in the battery. Looking at the bottom center, we see lithium iron phosphate. So that's the lithium battery compound. You see the compound name, and you know it's a lithium ion battery, not a lithium metal battery. And it's most certainly a lithium battery. In the DOT classification system, there are different names and ID numbers for different lithium battery types and configurations. So a United Nations or UN ID number is an identification number that is used for hazard communication purposes to clearly identify the material in transportation. In the lithium battery recycling supply chain, both lithium metal and lithium ion batteries are often present together in the same package. So what that means is that multiple UN ID number markings, for example, UN 3480 and UN 3090, are found on a single package or even sometimes within a single marking. And we'll talk about this in just a little bit. Jordan hinted at it, but the size of lithium batteries is an important consideration when determining what regulations apply in transportation. And again, generally speaking, for the purposes of the regulations, a smaller battery will not exceed the sizes listed in this table. For ground transportation only, some slightly larger batteries can be considered small batteries. In this presentation, we'll talk about some of the differences between how small and large batteries are packaged and communicated for transportation. And as Jordan said, remember when we talk about size, we really mean energy capacity, not the physical size of the battery. Many consumer electronics you're going to come across are going to fall into that small battery threshold. For example, a typical laptop battery might be around 60 watt hours. A cell phone battery generally isn't going to be exceeding more than 12 watt hours. Some electronics manufacturers may even specifically note that none of their product batteries exceed 100 watt hours. This is them sort of communicating to you that their batteries meet the small battery definition. Larger batteries, like those that power hoverboards or electronic bikes and scooters, will most likely exceed the 100 watt hour rating, but may fall under the 300 watt hour rating. So sometimes in the industry, people call this a medium battery. However, as it's not a term that's in the HMR, for the purposes of the regulations, know that it basically means a battery qualifies for the small battery exception by ground, but is fully regulated when transported by other modes, like shipping by air. A lithium-ion battery from an electric vehicle is even larger and has a very substantial watt-hour rating. Remember, lithium-ion batteries will be marked with their watt-hour rating. So let's do some math. The watt-hour rating should be printed on the lithium-ion battery for easy identification. If it's not, as is the case in this photo, the watt-hour rating of a lithium-ion cell or battery is determined by multiplying the rated capacity of a cell or battery in ampere hours by its nominal voltage. Therefore, the watt-hour rating equals the ampere hours, or AH, multiplied by volts, or V. If you're presented with milliampere hours, or MAH, you divide the value by 1,000. So let's take a look at this example here. We look at it and we don't see a watt-hour rating printed on the battery, but we know our calculation is ampere hours times volts. And we see 1,600 milliampere hours and divide that by 1,000, giving us 1.6 ampere hours. Multiply 1.6 ampere hours by the voltage, which is 7.2 volts, and we get 11.52 watt hours. So using that easy calculation, we know that this battery is considered a small battery under the DOT regulations. I'm pretty sure that's the end of the math for the presentation, which is good for me. We mentioned also DOT compliance can be thought of in having 3 prongs. So we cover the first, or classification, in identifying and classifying your batteries. So next up is packaging. The hazardous materials regulations cover all types of packaging for hazardous materials, from your large cargo tanks you see down the highway or rail tank cars to small fiberboard boxes and drums. For lithium battery shipments, you're most likely going to be using boxes and drums. So the biggest takeaway for lithium battery non-specification packaging is that it's largely performance-based. So what I mean by that is that the regulations don't specify or prescribe a particular packaging configuration that you have to use when recycling smaller consumer batteries, only that it must meet certain minimum general requirements. These general requirements are including protection from short circuits, as well as some basic configuration requirements. Packages should essentially consist of an inner packaging cushioning material if it's needed to meet these performance requirements, and an outer packaging that inner packagings are placed into. We'll go into the basic requirements behind each packaging component and give some examples that we've seen being used in the industry with some success. So what you're seeing here on this slide is the baseline for packaging small lithium batteries by highway for recycling and disposal. The inner packaging has some basic requirements listed here. Again, the key takeaway is that they are a performance requirement. The inner packaging is the primary means of preventing short circuits and mitigating the risk of spark and potential thermal runaway. Equipment that a battery is installed in can be used to meet the requirements for an inner packaging. Other common examples are plastic bags or taping the batteries. And a common question Jordan and I get is, can batteries be within the same inner packaging? Like, can you have multiple batteries in the same, inner? And example would be, taped in a row. And the answer is yes, provided there is no terminal to terminal contact and you're satisfying the performance requirement. So as far as not satisfying the performance requirement, here's an example from an investigation of what could happen when batteries are placed in the same inner packaging end to end, allowing terminals to touch and short circuits. So again, this isn't an acceptable form of placing batteries in the same inner packaging. You see at the bottom center, you have those batteries, their terminals are touching one another, can definitely cause a short circuit. Here's some better examples of inner packagings that provide terminal protection. Inner packaging completely surrounds the cells and batteries, and the terminal protection requirements are met. We see taping or bagging individually, or the ravioli method in the bottom left corner, where you take button cells and space them out on maybe like packing tape or another adhesive that covers the battery, and then place another layer on top. In the bottom right corner, you see cardboard partitions separating the batteries that are within individual bags. I've even seen recyclers use bagging machines to process large volumes of lithium batteries and satisfy this extremely important performance requirement. The regulations are going to require cushioning when it's necessary to prevent movement that will damage batteries under expected transport conditions. So what I'm talking about here is shifting, vibrations, and maybe small drops. Cushioning materials must be electrically non-conductive and non-reactive. The purpose is to prevent movement that could damage the batteries in transit or cause cell-to-cell contact. Some examples currently sold by commercial suppliers of packaging include bubble wrap, diatomaceous earth, and vermiculite. But any method is acceptable provided it meets the performance requirements. An outer package needs to be rigid, strong outer packaging. It has to be sturdy, durable, and constructed to retain its contents. And it also has to meet these performance requirements from a 1.2 meter or around a 4-foot drop. And rigid packaging is really important here. Flexible or padded shipping envelopes might seem like an affordable, easy way to ship a small item like a battery or two. And while these may meet the drop test requirements, they're not sufficiently protective from impact and handling in sort systems. And DOT actually saw incidents as a result of this and modified the regulations to specifically require rigid outer packagings. The package doesn't need to be UN specification packaging. And I'm going to show you that next, what we mean by UN specification packaging. Fiberboard boxes and plastic or metal drums are possible options. Any packaging, again, meeting the performance requirements is going to work. I just mentioned UN specification packaging. So on this slide, notice the letters, the circle with the letters UN, and it's followed by a bunch of numbers and letters. This marking on a package indicates that it is UN specification packaging. UN specification packaging is rated and tested to contain hazardous materials while standing up to substantial stresses encountered during transportation, so things like stacking, leaks, drops, and pressure changes. Batteries sent for recycling or disposal by motor vehicle, even larger batteries or quantities, are accepted from UN specification packaging requirements, so you won't have to have that. However, that same exception does not apply to rail or vessel transport of larger batteries and quantities. UN specification combination packaging, so an inner and an outer packaging, is required when transporting larger lithium batteries or quantities, seen here, for transportation for recycling by rail and vessel. This UN specification packaging must be rated to a packing group or PG2 performance level. So in short, it means the package was specifically designed and tested to contain lithium batteries. Packaging instructions will be provided by the packaging manufacturer, and you have to follow them exactly. So this includes using all the specified packaging components. This image shows an example of a packaging in the packaging code mark you'd expect to see on a specification packaging. However, that code is going to vary depending on the packaging type. So if you're transporting electric vehicle or electric storage batteries, you might be looking at that and thinking, I don't really have packaging available that's suitably sized for this battery. So in the hazardous materials regulations, we don't have a section that says, here's what you do for electric vehicle or electric storage batteries specifically, but there are provisions for transporting lithium batteries of this size in an alternative manner. You can palletize or crate large batteries over 26.5 pounds without further packaging, provided they have a strong impact-resistant outer casing. You don't define what the term strong impact-resistant outer casing is in the hazardous materials regulations. Keeping these batteries in their strong impact-resistant outer casing, though, is what can allow you to take advantage of alternative packaging methods like palletizing the batteries. When you're palletizing, the pallet should be larger than the battery to ensure sufficient protection from damage during handling and transportation. Batteries without or removed from their strong impact-resistant outer casing must be packaged in strong outer packaging such as a box or a crate. So moving on to our third prong of DOT hazmat transportation compliance for lithium battery transportation for recycling and reuse is hazard communication. This is what helps ensure a package of lithium batteries does not get mishandled in transportation. This can help decrease the risk of a hazardous materials incident that puts lives at risk. In the DOT regs, hazard communication includes package markings, labels, placards you see on a vehicle, also shipping papers and emergency response information. However, not all of these components are necessary for lithium battery recycling shipments. In fact, the requirements for small lithium batteries for recycling are going to be limited to package markings. Speaking of, this is the lithium battery handling mark that must be placed on packages of lithium batteries. There are some requirements around minimum dimensions shown below the marking. However, the dimensions may be reduced to 105 millimeters wide by 74 millimeters in height should the package be too small for the normal marking. The hatching on the marking must be red, and that first star you see under the image of the battery would be where you replace it with the UN number or UN numbers appropriate for the battery type or configuration in that battery. So for example, UN 3480, UN 3481, 3090, and 3091, indicating whether or not it's a lithium metal or a lithium ion, or maybe it's contained in or packed with equipment. You can write in more than one ID number on a marking if necessary, or you can use multiple markings with different ID numbers. Commercial suppliers are going to sell these pre-printed or blank, and you can handwrite information on these markings provided that it's durable and legible. That double star you see at the bottom center of the marking is where you'd replace it with the telephone number available to provide information on the shipment. For the telephone number, it's important to keep in mind that this does not need to be a 24/7 emergency response provider like other hazmat shipments. The number simply needs to be an individual that can provide information about the shipment if needed. And again, reminder, don't list a third-party emergency response information provider unless you have a contract with them or their permission. The regulations also require you to communicate that the package is forbidden aboard passenger aircraft, unless the package contains batteries installed in devices not exceeding 5 kilos or 11 pounds net weight. There's some text statements that can be printed or written on the package, or alternatively, the cargo aircraft only label you see here on the right can be used. The cargo aircraft only label or statement, written text statement, is required by all modes of transportation. So you have to use the label, not the text marking, if you're shipping packages bound for international destinations. So if you're shipping small lithium batteries for recycling, you have to use this marker label even for ground transportation. Here's an example of a package that contains smaller batteries. So for example, let's just say they're cell phone batteries and they're ready for transport. It's got the inner packaging, it's got the cushioning, and now we see our outer packaging here, this plastic drum. You see the DOT handling mark and the cargo aircraft only label, but also notice the universal waste marking. This is not a DOT marking for transportation, but it's an EPA marking that you'll see when you're managing batteries under universal waste for recycling or disposal. A universal waste marker label to identify the waste should be applied in accordance with 40 CFR section 273.14 or 273.34 to identify these batteries as universal waste. And again, another reminder that in your handouts, the regulatory citations in the bottom right-hand corner, you should be able to link to those regulatory sections. And the marking can state universal waste with a specification that the type of universal waste is batteries, or it can say waste batteries or used batteries. And one last thing to note about this, that it should be said that this marking doesn't just apply in transportation, but also during the collection process. If you have larger batteries, the regulations are also going to require you to indicate that the package is forbidden by all aircraft and vessels. This is a text statement that can be printed or written on the package you saw on the previous slide. If you're shipping larger quantities of batteries or larger batteries, you'll be subject to increased hazard communication regulations, as these are considered fully regulated Class 9 hazardous materials. First is shipping papers. The shipments are going to require a full hazmat shipping paper that includes all the shipper's certification and hazardous materials description requirements. Secondly, it should be accompanied by emergency response information and a 24/7 emergency response telephone number. The package is also going to require full DOT hazard markings and labels. And let's take a look at an example of what that package might look like. So here's an example of our fully regulated Class 9 lithium battery box, and it's meant for recycling by motor vehicle. You can see all the required description elements for the package. Full hazmat shipping papers and emergency response information would be required. You see the consignor or consignee name and address, so that's the person sending or receiving the package. You see the UN ID number and proper shipping name. In this example, it's UN 3480, lithium-ion batteries. And then you see the Class 9 lithium battery label, which is different than the small lithium battery handling marking. And in that box, you see the UN specification packaging code, where UN specification packaging would be required for rail and vessel, but remember, by motor vehicle for recycling, you are accepted from the requirement for UN specification packaging. DOT does have training requirements for shippers and carriers of hazardous materials. But for those of you that only ship small lithium batteries for recycling, so your battery is under 300 watt hours and under 66 pounds gross weight per package, you're not required to have formal training in accordance with the DOT hazardous materials regulations. Employees working on these shipments do, however, have to be familiar with the requirements related to shipping under the small battery exception. But your larger shipments of batteries, so those over 300 watt hour batteries or 66 pounds gross weight, or those who ship damaged, defective, and recalled or DDR batteries, do have to have formal training. DOT hazmat training consists of general awareness and familiarization, function-specific training, safety training, and security awareness subject areas. If you do find yourself in need of this training, there's a few things to note. First, DOT does not offer the complete formal training, but we do have a lot of free resources to help meet the training requirements on our website. Specifically, DOT offers free online training that will meet the general awareness and familiarization and security awareness requirements. So at a minimum, 2 of your 4 parts can be taken care of for free through our website. A company also has the option to develop and deliver their own training program to their employees using DOT or other resources to supplement. Companies can also hire a third-party trainer to certify their employees. So we don't have a requirement on the minimum number of training hours an employee receives. So, OSHA has WOPR training, they have the 8 or 40-hour course, but DOT doesn't have anything like that. Nor are there requirements that state that the training has to be delivered in person. So at the very end of this presentation, I'm going to share a lot of these resources with you. But let's hand it back to Jordan, who's going to talk to us about some special topics.
All right, thank you. While Neil takes a break, I will go through some of our special topics, the first one being damaged batteries. So I'm going to talk a little bit about the DOT requirements around these batteries specifically. Damaged batteries present a unique safety hazard in that they're batteries that have been identified as being at an increased risk of producing a dangerous evolution of heat, fire, and short circuit. This kind of thermal event can spread to other batteries that were not otherwise damaged and propagate thermal runaway and a potentially catastrophic event, as we've seen in past incidents. So because of this increased risk, there are some unique requirements to keep in mind when dealing with damaged batteries and their transportation. So the first requirement is identification. The tricky thing about damaged batteries is that they may not always appear damaged in a physical sense. Severely swollen or leaking batteries can be easier to spot because of the physical manifestation of that damage. But other batteries may look fine, but they may have been identified by the manufacturer as specifically being defective for safety reasons. And in the recycling waste stream, it may not be practical to be able to know this information easily. The major challenge for the recycling industry is that lithium batteries and equipment in the disposal and recycling transportation streams often originate from unknown sources and may have been subjected to abusive conditions resulting in unseen damage. In addition, some batteries in the waste stream may be counterfeit. They were never subjected to UN 38.3 battery tests, which means the battery may present an inherent safety hazard. So again, damaged batteries and DOT regulations are those that have been identified as being at an increased risk of producing a dangerous evolution of heat, fire, and short circuit. And identifying damaged batteries really comes down to making a professional assessment and evaluation of the battery, which can be difficult. So while the language in the HMR does not give too much specificity, there is language from the UN model regulation seen here that may be helpful when you're trying to make a determination. So some criteria that you can look for in a battery include, but it's not limited to, batteries that are known to be defective, batteries that have leaked or vented, batteries that have sustained physical or mechanical damage, those batteries that can't be diagnosed, can't say for certain whether they're damaged, but suspect it. Some stakeholders report that when they're in doubt, they consider classifying as a DDR battery because of safety implications. But again, you're making a professional assessment and determination about the battery. Some stakeholders in the industry also report that what they're looking for sometimes certain smells of corrosion or loose wiring. But when assessing these criteria, the language will state in the UN model regs, consider an evaluation of acute hazards such as gas, fire, or electrolyte leaking, misuse of the battery, any known misuse, signs of physical damage, deformations, changes in colors, not talking any minor superficial damage. And then again, any damage to safety features, safety components, or short circuit protection in the battery. So examples of damaged batteries, again, they can range from physically damaged to those that are just known to be defective, like certain hoverboards several years ago, or specific manufacturer recalls like the Samsung Galaxy Note 7 recall in 2016. The packaging requirements for damaged batteries is going to be very similar to that of other lithium batteries in that the requirements are following the same basic configuration of inner packaging, cushioning material, and outer packaging. Some key differences here include the fact that you are limited to one battery per package, and that package needs to be a UN specification package rated to the most stringent standards, which is known as Packing Group 1. This is obviously very restrictive, and for good reason. Until recently, transportation of damaged lithium batteries was simply forbidden unless given written approval by the DOT. And again, these are the batteries that are presenting an increased safety risk and need to be treated as such. If this seems daunting, we'll talk about some options, namely the use of DOT special permits in our next special topic area. Here's an example provided by Cascade Asset Management. In this case, they were putting vermiculite inside the inner packaging as part of their packaging design that they were using. What is important to remember, though, about packaging design is that when you are using a UN specification packaging, like in these cases, you must use it exactly how it was tested. So this includes using all of the exact packaging components specified by the packaging manufacturer. Now, in terms of hazard communication, the package requires largely the same markings and labels as fully regulated batteries, though there is an additional marking requirement to mark with an indication that the package contains a damaged or defective battery. This text phrase seen on your screen and must be at least ½ an inch high. So here's an image of a sample package. Again, very similar to fully regulated in its hazard communication. Just note the additional marking requirement. And also note that if you're using a special permit packaging, we'll talk about right on the next slide, there's an additional DOT SP followed by the special permit number that must be marked on the package. So now we'll discuss DOT special permits. So as we've mentioned before, because of the unique challenges faced by this industry, PHMSA has issued a number of special permits that all offer alternative provisions to the regulations that we've outlined so far today. So what are special permits? They simply authorize an action that is not otherwise permitted in the regulations as written. When special permits are issued, they're closely evaluated to ensure that measures are taken to achieve an equivalent level of safety to the regulations. And in this way, they're acting as extensions of the regulations. So DOT special permits are extremely common in this industry, and they must be followed according to the exact terms of the special permit. So there are two main types here on the screen, two main types of special permits. The first, MMS, means manufacture, mark, and sell. It authorizes a packaging manufacturer to manufacture and sell packaging that can be used by any individual. The use of that packaging grants certain exceptions as specified in the special permit. This could include, but it's not limited to, allowing for the mixture of certain batteries not normally authorized, providing alternative inner packaging requirements, so maybe tape terminals, and they may provide exceptions from certain hazard communication regulations. The second main type of special permit is known as offer special permits, and these are issued to a specific grantee to operate outside of the regulations. So this, again, could include alternative packaging or hazard communication. The key difference is that these permits, these offer special permits, are issued only to one grantee. So for example, a company or municipality may have a special permit to privately transport batteries with little regulatory requirements, or perhaps a shipper wants to ship large bulk quantities of batteries for disposal by vessel rail in ways not ordinarily authorized. It really could be anything. A special permit really could authorize anything that's not ordinarily permitted in the regulations. And they do sometimes offer party status, meaning that you can also become a holder of certain special permits. So these are just some representative examples of DOT special permit packaging. Not an endorsement of any particular product or company, just good examples of MMS permits that you may see in the industry. Big green box, call to recycle. Anyone can use these packages provided they follow the terms of the special permit, which the manufacturer or company generally is communicating through instructions or training. And now here are some examples of what are known as DDR kits for those damaged, defective, recalled batteries. This is special permit packaging for damaged batteries, commercially available to purchase from manufacturers. Now, some advantages to using DOT SP DDR kits may be that they allow for more than a single battery to be placed in a package, or they may allow for mixed chemistries of DDR batteries being transported together. Again, like all special permits, these packagings have been determined through testing by the manufacturer and evaluation by the DOT to meet an equivalent level of safety to what is in the hazmat regulations. So for this reason, these packagings can be a vital tool for the transportation of damaged batteries for recycling or disposal when you're faced with a high number of damaged batteries, and one battery per package is not practical. So we encourage you to explore the many commercially available options out there when determining your packaging needs, or even reaching out to DOT, our special permits office, when you find yourself with a need there. So here's another example of an MMS DDR kit. This one is designed to ship up to 4 pounds of damaged batteries. So the manufacturer, as you can see, provides shippers with specific packaging instructions on the use of the packaging. These instructions align with the terms of the DOT special permit. So a purchaser of this packaging must adhere to these manufacturer instructions exactly as they're written when using the special permit packaging. It's important to note that these instructions can't be applied when using other packaging. So for example, you would not follow these instructions unless you're actually using this packaging, which is specifically manufactured and tested for this hazardous material. Instructions for these packagings are not general guidance or regulations for shipping all damaged, defective batteries. They're only applicable when using this specific special permit packaging. Also want to note that the terms of certain DOT special permits may include additional training requirements for shippers using the packaging. So you may need to train hazmat employees on the use of that permit, and that training, like all other DOT training, would need to be documented. And so with that, I will turn it back over to Neil again to discuss some compliance resources for you moving forward.
Thanks, Jordan. So before we leave you today, we wanted to make sure that we gave you some resources and tools to kind of help you with compliance assistance or regulatory compliance. So PHMSA supports our regulatory compliance through the development of compliance assistance materials. We also conduct live outreach activities like hosting in-person workshops and webinars like this presentation. PHMSA also publishes the Emergency Response Guidebook, or ERG, that orange book that's pretty well known for first responders. That includes emergency response information for first responders to guide them in hazardous materials incident response. So again, the handout section of this GoToWebinar has a PDF version of our presentation, and you should be able to navigate to these resources as well as the other URLs or regulatory references throughout the presentation to assist in finding what we're going to show you. So Jordan told us about DOT special permits or DOT SPs. So for locating DOT SPs like DDR kits, you navigate to our approvals and permits page. There's a search function there for approvals and for special permit search. And the tool is really easiest to use if you already know the company. So for DDR kits, that'd be the manufacturer of the package. or you know a DOT SP number. So if you're at a recycling facility or you're given a package and you see it marked with a DOT SP number, but you don't have the document, go on our website, type in the document, see if it's there. Although, like Jordan mentioned, those permits should accompany shipments. Unfortunately, the search isn't like a search engine. We don't have that capability to help you find keywords in special permits, but it's where you locate copies of special permits or information on even applying for special permits. Maybe you need an offer permit for kind of out of the box situation with recycling, or you're a manufacturer of packagings that would be used for recycling lithium batteries. I mentioned training before being required for shippers of larger batteries or DDR batteries, and those folks would need formal training. And I mentioned the training modules. This is a great place to get started with that process. It's an online portal where you can go in, you create a login, and you can complete the modules covering areas like shipping papers, markings and labels, packaging, and more. Completing the modules is going to satisfy at a minimum your requirement for general awareness and familiarization training, as well as security awareness training. You can kind of come and go as you please. So if you don't want to sit around and go through the whole thing, that's fine. Come back at another time. It'll keep track of your progress. Also, it's pretty great for record keeping because each time you finish a module, it's going to give you a certificate that you've completed it. Each module also has a minor testing component to satisfy the requirement for training to include testing. So if you're responsible for having hazmat training or training your employees, this is at least an excellent first stop on getting you there, and you can kind of see what you're dealing with. We also develop and maintain a number of publications on our outreach and engagement site. These publications are completely free digitally. You can get them and order them to be printed and shipped to you, and they're going to assist you in hazmat transportation compliance. So they cover a broad range of topics, so we definitely encourage you to take a look at the list of what we have there. Some examples are the DOT Chart 16, which is our guide to DOT marks, labels, and placards, and how to use the hazardous materials regulations. And we even have material-specific publications, so a publication on cylinder requalification or transporting infectious substances or fireworks. We're constantly updating and trying to create new resources for you to use. Our latest, I've linked there at the bottom, this is brand new, is our e-resource guide. So it's digital only, and it's called 7 Useful Tips. This is a really great resource for those that are asking the question, I want to ship hazmat, where do I start? Fantastic resource that's going to kind of link you to all the different things you need. PHMSA also has videos and apps to help with compliance assistance. Some of our apps include the ERG, or Emergency Response Guidebook 2020 app, the Chart 16 app, the Cylinder Requalifier Locator, and the OCFR app. These are all on iOS and Google Play stores. Our video section includes, how to use the ERG if it's your first time approaching the book, and training webinars that are going to get you help getting started creating training programs in the workplace. So if you're starting up a training program and you are not sure where to start, there's a pretty nice video that's going to kind of walk you through developing a training program. Next, we have the OCFR, or Online Code of Federal Regulations. As a dork, this is my favorite tool to show folks who are interested in kind of like leveling up their compliance and regulatory toolbox. On the surface, it's just a snapshot of the hazardous materials regulations, same as the printed book, updated every year. However, what's different about this tool is that it does link specific regulatory citations. So for example, if you're looking at the lithium battery section, 49 CFR 173-185, it's going to link that section with all the rulemakings, special permits, and letters of interpretation that deal with that section. This is also a searchable database for letters of interpretation to locate them by keyword. So if you call me or email me and ask me a question about a letter of interp, this is the exact same tool that I'm going to use to try to find those letters, and it's completely free and available to the public. I really can't recommend it enough if your job is to do regulatory compliance with the hazardous materials regulations. The Hazardous Materials Safety Assistance Team is another resource for you. That team includes myself and 5 other hazmat transportation specialists from around the country who are located in the different regions and responsible for face-to-face outreach and compliance assistance. So our main goal is to make complying with the regs more accessible, connect you to resources to help you transport hazardous materials safely. We host in-person events like workshops, attending conferences, serving in emergency response community groups, and conducting regular webinars on the DOT regulations. These webinars are going on monthly and are completely free informational sessions that give you the basics of hazmat transportation. So what they started off is, last June was a way to supplement our loss of in-person events during the COVID-19 pandemic, but they've been really successful and popular, and people seem to like it. So we plan to continue them as long as folks are interested. I've included that link here at the bottom, and it's on your handouts where you can go and register and see the schedule of stuff. I think it's, you might not see anything for a few days, but we're putting up our May offerings pretty soon. Also, if you need help with compliance assistance questions, give one of the HMSAT members a call. That page does link to your specific region's representative. The last resources I want to point out to you is the Hazardous Materials Information Center. This is especially near and dear to Jordan and I, as we both got our start in DOT hazmat regulations working in this call center. So this is a free resource where you can talk to a live person with your regulatory questions regarding hazardous materials transportation. Their staff 9 to 5 Eastern Time, Monday through Friday. If they can't answer your question, they can find someone who can. So definitely encourage you to save this number and use it, as it's an invaluable resource. I even find myself calling it from time to time when I just, have a question I can't quite figure out on my own. Finally, I want to take a moment to recognize everyone who helped make this event happen, between DOT and EPA staff, contractor and administrative support. We had subject matter experts from industry weigh in. We had our advocates that helped us spread this important safety message, sent this out, tried to promote the event. This is a really long list of people who had an influence on making this happen. It's not just us. So Chris, Jordan, and I want to express our sincere gratitude to everyone behind the scenes. Thank you so much. I also want to specifically shout out Kathy Lett and Christina Torres from EPA. They were with us every step of the way, and without you guys, we could not have made this happen. Also at DOT, Kevin Leary, our professor of lithium batteries, definitely has helped Jordan and I with basically every single thing we've done on lithium batteries. So thank you so much, Kevin. Here again is Jordan and I's contact information. Please don't hesitate to get in touch if you have questions about transporting lithium batteries, or if we can assist you in other areas of hazmat transportation. Thank you to EPA's Sustainable Materials Management Web Academy for hosting the DOT today. We're always really glad to partner with you. And finally, thank you so much for attending and taking time out of your busy day to further transportation safety. Thank you. Goodbye.
All right, we wish to thank today's speakers for their insights on the safe transportation of lithium batteries. And most of all, we want to thank you for joining this SMM Web Academy and hope you continue to join us. It is you that this program is designed for. So please make sure you complete our evaluation. We value your feedback because it helps us meet your needs. We will post today's webinar recording in about 2 weeks and the slides next week. And please join us for our next webinar on May 25th at 2 p.m. Eastern on innovative reuse and recycling contracts, where the U.S. Forest Service will share innovative contracting approaches to reducing and managing materials to advance source reduction, reuse, and recycling. The registration link will be posted shortly on the SMM Web Academy website. So this concludes today's EPA SMM Web Academy session. Thank you.